So yeah, hi, I'm Marcel, and we looked at how we can encourage users of Jupyter notebooks to use less energy. In Swedish, there's the term flickskam, describing the feeling of being ashamed of flying because of the carbon emissions. And we wanted to research how Jupyter notebooks can produce similar emotions. So first, maybe what are Jupyter notebooks?
We can't see your
popular
screen.
Tool.
The screen doesn't seem to be sharing. Can you just stop sharing and start again?
Oh, sure.
I think
yeah.
Just seems to be a glitch.
Yeah. Oh, hang on.
We still can't see it. We just have.
Yeah. Okay.
No. Can you try sharing the entire screen, maybe, if you were sharing a window or sharing the window?
Oh, I see. Yeah, now it should work.
No. Do we want to try sharing on our side then?
Yeah,
sure. We're going to share it on our side and you can take control of the screen.
Okay, also nice.
Yeah, you need to request remote control, or maybe we can give it. Okay, you should be fine now too.
Okay, amazing. I can't go to the next slide. Can I just say next slide and you advance? Is that maybe fine?
Yeah, let's do that.
Yeah. So yeah, next slide. Okay. Yeah, Jupyter notebooks are a popular tool for data science and machine learning, two of the most power-hungry disciplines. And usually a Jupyter notebook server is running somewhere and you connect to that from your browser. You get some sort of document where you can write text and also code snippets called cells, and these run in the server. There are free services for that. For example, Google has one. And that's great because it enables everyone to tinker with data science and machine learning without requiring beefy hardware. But on the other hand, that abstraction from the hardware means that you have no idea of the resources you're using. So in your laptop, it may just look like a few lines of code, but in the background, there's a huge server rack that's spinning up and running. So we want to apply the concept of flickskam to Jupyter notebooks by showing you the energy you use. And the first step to that is measuring energy use. Next slide. Yeah, so luckily there are a few ways to do that. In the last presentation, we already heard about the running average power limit, or RAPL for short, on Intel CPUs. For NVIDIA GPUs, there's also the NVIDIA Management Library, or NVML. And of course, you can always plug a physical board, like this microchip MCP power monitor, between the wall socket and your server to measure the energy consumption of the entire system, including things like the fan or the disk or network cards. So we have all this information about how much energy is used. And next, we want to show that in Jupyter notebooks. Next slide. So there are a few related extensions that do something similar. The most popular one by far is called Jupyter Resource Usage, and that can show the RAM that your notebook is using, as well as the CPU utilization. And since we started working on this, another extension also popped up, Jupyter Power Usage. So it deserves an honorable mention here. It has a very similar architecture. Next slide. This is how those extensions work. So one component is running in the notebook, in the browser, and it can, for example, add new UI elements. Another component is running on the server. And in our case, we also add an energy server that aggregates all this information. Next slide. So we wanted to focus on how to present this information to users. Rather than just showing a number, we want to make users understand that. Like to us at this conference, we know what a joule is. We know that it takes like 4.18 joules to heat 1 liter of water by 1 degree, but the average Jupyter notebook user doesn't. So we always try to show real-world comparison values, like this is enough energy to make a toast or to brew some tea. You can also see the energy use over time, and you can see the energy use of individual components, like the CPU or the GPU. You can see the long-term energy use for long-running tasks, and you can see how much of that energy comes from renewable sources, based on some publicly available information. Yeah, next slide. So as Didi mentioned, the overhead of these tools should also be measured, because if the overhead of the tool itself is large, then it kind of defeats the whole point. So we did some early evaluations with a few different benchmarks, one that just weights, and then a memory-bound and a compute-bound algorithm. And finally, a real-world Jupyter notebook from a university lecture here. Next slide. These are the results. So first we noticed that the internally reported energy use is less than the externally measured one. And that makes sense because the external one also includes extra peripherals like the power supply, the disk, the fan. And next, these benchmarks are kind of noisy, and maybe the green metrics tool can help with that a bit. But yeah, we figured that there's an operating system that runs things besides our code. So yeah. And finally, we were happy to find that enabling the extension doesn't significantly impact the energy use or the runtime of the code. That means that we can, in good conscience, just enable the extension by default. Next slide. And enabling the extension is exactly what we're planning to do in 2 user studies early next year. One in the AI Service Center in Berlin-Brandenburg, and the other one in a data science lecture at a university. We want to separate people into 3 groups. For one group, the experience doesn't change compared to the status quo. For another group, we just enable the extension and that's it. And for a third group, we also ask them to reduce the energy use. We'll compare the final readings, and we hope that at least for some people, just showing them the amount of energy they use already makes them change their behavior. We also want to prepare a balanced questionnaire on how the extension influenced their activity and self-reflection, and with a Likert scale of how likely they would use such an extension in the future. Next slide. So of course, there's more stuff to do. We want to package everything up nice and tidy and simplify the installation. For the user studies, the estimation of how much of that energy comes from renewable sources is just hard-coded to our home city, Potsdam. We want to make that customizable. Of course, we can only measure ongoing energy use. So yeah, also from the previous talk, like the embedded or embodied carbon that was like the emissions that come from producing the hardware, they are not included in our model. And finally, more fine-grained attribution would be nice. So that would include like multiple users running on a single server, and maybe even highlighting the energy use of individual cells within a single notebook. And with that, we're looking forward to your feedback and your questions. And Didi, there was a lot of overlap. Maybe we can meet up if you're also in Berlin. Thanks.
Okay, thanks. What do we want to do for time? I don't know what you want to do. Do you want to take a question or? Yeah, okay. Yeah, maybe a couple of questions.
Thank you for that talk, really interesting. I have a question regarding the user study you're planning to run. So there'd be a 4th group that I thought you wanted to include, which would be asked to reduce the energy consumption without the intervention. And I wondered if there's a reason you haven't included that.
Well, we could do that, but we felt like people had basically, like it would be a little disheartening to see people, basically you have no way of knowing the energy use of your code. But yeah, I guess for the baseline, like that would be nice, just seeing that the extension enables people to reduce the energy if they want to.
Yeah, exactly. Just as the comparison to see if the extension kind of.
Yeah, I think that makes sense. We can add a 4th group.
Thank you.
We have a question online if there is still some time.
Sure.
So it's from Dan. So it's energy use
Go
of a
online.
single cell.
Yeah, go. We can ask the one online.
Yeah, so the question says energy use of a single cell in a notebook would be really cool, but are there any technical barriers to that?
So we can, for example, we can just see when does a cell start executing and then measure the energy consumption and then stop the recording when the cell is done. That should work. But of course, there are dependencies between cells, and you don't have to you don't have to run the cells sequentially. You could also run one cell multiple times, for example, if you change some data. So the question is, how do you represent these dependencies? But I think there are no big technical barriers to that, as far as I know.
Okay.